Speaking of customers, I brought in a couple of my favorite calendars here. One is the SDSC SIM calendar, and they have a nice January picture on protein folding. Now, we of course are doing some business with some of SDSC's friendly competitors. I won't only list them. I have up in my wall, which I've had for a couple of years, the Mississippi State Sim Center calendar, and they're doing a space shuttle launch pad simulation in January. So certainly at the end of the day, all of the hardware performance aside, what really matters is getting that performance out of the applications. And finally here I have something from the Weather Research Forecasting Model, WRF. And I know we've been working with a lot of weather customers. We recently won a large deal at the Brazilian Weather Service running where WRF is one of their applications. What are we doing at Sun to try to optimize application performance for WRF and other codes on these new multi-core processors?
So WRF is actually very interesting code in the sense that it needs balanced system hardware and software. So this whole notion of designing the systems that balances the three things we think are critical to the real-world application performance rather than just pure flops. Those three things are the memory bandwidth, interconnect bandwidth, and I/O bandwidth. And the interesting thing about WRF, it stresses all three in different parts of their code. In other words, if the system doesn't have a good parallel file system with high throughput I/O, you're bottlenecked by. So as you scale the application as you increase the number of processors the WRF runs on, the more and more time now you are more and more fraction of the total time will end up spending on the I/O because your system doesn't have the I/O necessary to absorb the data generated by these timestamps of the weather fields that it dumps out every so often. So WRF. We use these applications and understanding of these applications to design well-balanced systems from ground up, both in terms of the hardware and software, and how we configure these systems and architect these systems.
So I think that's a real interesting point. Is I know in the past when we had large enterprise servers, large SMP servers like the 25K, that balanced architecture was really built into the system and the system cabinet. So it sounds like a lot of what we're doing today in building balanced systems architectures is really thinking outside the box, outside of the server, and really expanding out into the networking space with InfiniBand, out into the disk storage and the disk access space. So we're still focused on building an overall balanced system, but it's more by assembling components outside the box than inside the box. So that's when we'll have to go talk to Jack in the Box about their naming, see if we can get that URL. Now,